Alrighty, this is my tutorial on how to solve problems involving inclined planes. Let's say that we are looking for the rate at which a box is accelerating down. We'll say it's a smooth incline, so negligible friction. So I want to know this acceleration. I have the mass and I have the angle. First thing we should do is draw a free body diagram for the box. So we know gravity is going to pull straight down. The normal force will be perpendicular to the surface, the inclined plane. If we did have friction, remember it would be perpendicular to the normal force. So if the box is sliding down, it would be up the incline. If the box was being pushed up or sliding up, then the friction would be perpendicular to the normal but parallel to the plane and down the plane. But for now, let's just assume smooth incline. And in order to get the acceleration, here is my tip. Always make the acceleration positive, and in this case, make it one of your axes for your coordinate system. So we might have been used to a coordinate system that looks like this. But we could just rotate these axes so that the y is perpendicular to the plane. And in that case, what happens is if we're looking for the acceleration, we want our net force. And since our acceleration shares the same direction as the net force, then when we get our resultant, we won't have to mess with that. So I guess I could better illustrate it. Let's say if it was a rough surface and there was friction, by rotating our axes, notice that we go from having just the weight on one of the axes. In this case, it would be the negative or the downward on the y. By rotating our axes, we go from just having the weight along an axis to having the normal force and the friction along an axis. So that's why we rotate, because it means we only have to resolve one of the forces in this moment. So back to our smooth incline. So we're going to leave the normal force alone, and we're going to resolve the weight of the object, or the gravity acting on the object, along those two components. So we'll have a y component and an x component. We need to know what the angles are in this triangle. Remember, the y and the x should always be perpendicular to each other. I typically, when I see this drawn, I'll typically see it like this. If it's incorrect, notice that the student that writes this or draws this is making one of the components perpendicular to the resultant, and that's not what we want. So we're going to stick with this triangle over here, and we're trying to figure out what the heck this angle is. Well, remember, we have theta up here. Gravity is pulling straight down. So in this triangle to the right here, the upper angle would be 90 minus theta. Our y component is perpendicular to the surface, so that makes this angle 90. For any given line, the degrees for a line is 180. So if we have 90 minus theta, our angle here should be theta. So let me redraw this triangle. MG. Our y component here's theta, and our x component. So our y component is mg cosine theta, and our x component is mg sine theta. So let's go back to our free body diagram. We have normal, mg cosine theta. Those will balance out, so our net force must be mg sine theta. So if I want that acceleration, mg sine theta over m, and it turns out I don't care what the mass is. The box or whatever is sliding down this incline will slide at g sine theta. And depending on whether or not you're looking at Galileo's experiment, if you know what the value of sine theta is at various angles, you can see why we say that for a free falling object its acceleration will be g. And there we go.